you're asked to find the absolute maximum minimum of a function y over the interval -2, 3. Now, because we've got square brackets around that, that's not an x and a y value. This is from x equals -2 to x equals 3. And the square brackets tells me that of this function here. So y and f of x are interchangeable, so that's f of x. We want to know the absolute maximum and the absolute minimum. Now, going back to our template, the first thing is to actually work out turning points. And we find turning points by dy dx. So we've got dy dx equals 6x squared minus 6x minus 12, and the derivative of 15 is 0. So turning points are when dy dx equals 0 and dy dx is 6x squared minus 6x minus 12. Now, to make that simpler, you can't divide by the unknown x, and we don't have an x here next to the 12, so we can't divide by x anyway, but that's just a little reminder. But we have a factor of 6 that's common, and 6 will go into 0 times. So we divide everything here by 6 and we get 0 equals x squared minus x minus 2. And either using the quadratic formula or factorisation, and if you're good with factorisation, it's always much quicker. 2 factors of x squared are x and x. And the only factors of 2 are 2 and 1. And this negative tells me that these signs have got to be opposites. And when I multiply along there and add those two terms together, I've got to get -1x. So the bigger one here has to be the negative, and that one has to be the positive, because when I multiply those two together, I get -2. Multiply along that arm, I get -2x. Multiply along that arm, I get +1x. You always add, and you get -1x, which is -x, which is the middle term. So I know that is correct. So these will be my factors, and that'll be x minus 2, x plus 1 will be 0. So turning points at x equals whatever makes that equal to 0. So x minus 2 equals 0, rearrange, you get x equals 2. Whatever makes that equal 0 will be x equals -1. Now we should at this stage check to make sure that these two turning points occur inside the interval. So -1 is certainly greater than -2, so it's to the right of that point, so yes, that's in there. 2 is to the left of point 3. So both of these x values lie in the domain from -2 to 3. So we'll have to do step 2, which is to evaluate y values. And if we put in x equals 2, we get y equals -5. By substituting 2 into the original equation, and we put 2 in that, we're going to get y is equal to -5. And when x equals -1, and we substitute -1 into the original equation, we get y equals 22. Okay, so the third step is to evaluate n values. So when x equals, the smallest value will be -2, and we substitute that once again in the original equation, we get y equals 11, and when x equals, the other n value is 3, we get y is equal to 6. So now it's a matter of scanning these 4 y values we've got. So the fourth step is to quote that the least value, well, what was the question? To find absolute max, and then say absolute minimum of the function. So we find the smallest value, and that will be -5, and that occurs at x equals 2, and the absolute max, in other words, for these would be the least value and the greatest value of the function. What is the greatest value? We'll go down the y values here. Which one's the biggest? 22 at x equals -1. So there we go. We've done the template, 4 steps. Find the turning points and then find the corresponding y values, and then evaluate the n values of the domain, see what the function's doing, and then you just simply scan along those and see which is the greatest and which is the least and quote your answer.